Hello and welcome to our Chapter 9 test review. You have a test Thursday, no matter which section you are in, over some of the things we've been talking about in Chapter 9. I want to make a quick edit though. I don't want to do all of Chapter 9. I know we had a whole quiz before I even left on paternity leave. And so I want the Chapter 9 test to only be trigonometry. I want to shorten it to only trig, so I want it to be 9.5 through 9.8, I believe. I think those are the sections we've done with trig. So we're going to do these 4 sections today, and we'll have examples for each of them. The beauty of a video is you can jump around. I'm going to try to make sure down here at the bottom of the bar I have the timestamps when every question is, so if you want to skip around, you can. There is going to be one additional question at the end that is only for honors. It is labeled such, so on level folks, you will have a shorter video than the honors people, but we will get to that at the end. So let me talk about the ideas that we did in trigonometry this whole time. We had the same ideas that we used again and again, and it was 3 different functions, trigonometry, and we had 2 kind of special formulas we used at the end. All of this will be given to you on there, but I want to make sure we talk about it. So you're not going to be memorizing this stuff will be given, but I want to make sure you know how to do it as if. Sine of x degrees, we'll put, that's your angle, is your opposite side over the hypotenuse. Every right triangle we know has a certain ratio when you look at opposite sides and hypotenuses, and that's what the sine is. The cosine is similar as well. Instead of the opposite side, it's the adjacent side over the hypotenuse. And then finally, the tangent is your opposite side over the adjacent side. These are just simple ratios that people have measured out before us. And you might see people refer to it as so and ka and toa. That is just a simple abbreviation for the different pieces. For example, the sine is the opposite over hypotenuse. It's the so. So really it probably should be something like this. That's another way to do it. It's S over H over A. Those 3 things. We used these 3 things, these 3 ratios, with right triangles. We used those exclusively with right triangles. We used a version of the sine and cosine, but when we were doing these ratios, that was only with right triangles. We had 2 additional equations we had. We had the law of sines and the law of cosines. The law of sines and the law of cosines. All very useful for solving any kind of triangle. So these, we did not have to have a right triangle. We could use them in a lot more cases. The law of sines was the sine of an angle over its side equals the sine of another angle over its side. We could have a third term here, but normally we're just setting up one ratio. So I can write it like that, that's fine. So I have sine of an angle over its opposite side. Law of cosines was a little bigger. A squared equals b squared plus c squared minus 2 bc times the cosine of a. That one's a little harder, but we're going to use this. We're going to do equations for both of those towards the end of the video today. Those are the big ideas you have to know. Everything else is coming from these pieces. We had calculators, we had trig charts that we used, so make sure that you know all of this stuff. If you need to, pause the video and copy it down. Now I'd like to get started on our first example problem. First example problem comes from 9.5. And we're going to be finding a side using trigonometry. So let's assume for a moment this is a right triangle. We're doing 9.5. So we are trying to find this side. I have my hypotenuse, and I have this angle right here, 58 degrees. First thing I have to do is figure out which one of my three functions I'm going to use: sine, cosine, and tangent. Well, based on the angle I'm given, I have the hypotenuse, and I have this. This is the opposite side from my angle. So if I have the opposite side and the hypotenuse, I don't have, nor am I looking for the adjacent side, I'm going to use sine. The sine of an angle is opposite over hypotenuse. I'm going to use a sine. I have to use a sine here, based on all the things I had. So it'd be something like this. Sine of 58, my angle goes inside there, is x over 17. Not 17 over x. X over 17, that's my opposite side, over my hypotenuse. Well, this is just a number. This is just a ratio of how much, what percentage of the 17 is this length. You have a trig sheet and a calculator. Either one works. If you're using a calculator, first thing to do is make sure you are in the correct mode. So I'd go to mode, that's right here, and double check that you are in degrees. Make sure like the fourth or third down says degrees. Well, if you are in degrees, you can turn this into a number. Sine of 58 is 0.8480. If you do not have, if you don't know how to use your calculator to do that, you have a trig sheet where it has columns 1 through 90 or 0 through 90. You would go to the 58th row and look at the sine column, and that would have this decimal here for you. Well, all I have to do now is multiply it by 17. And I can get my answer. I am always happy with answers being one decimal place. While I'm working, I'm going to keep as many decimals as I can. But for my final answer, I'm going to just trim it down to one decimal place. And I got 14.4. Remember, all we're doing in trigonometry, what we're saying is every time we have a triangle with a 58 over here in the corner, this side is going to be about 84% of the hypotenuse. That's all it is. It's a ratio saying every time we have this kind of shaped triangle, this is always 84% this side. So if this was 100, this would be 84. That's what we're doing. And so I get 14.4. All right. Once again, if you need to, stop the video. I would copy these down before I do each problem. That way you can follow along, pause as you do it, and be sure to go over the questions later again that night. So I'm going to do another one. Yeah, okay. Let's do another one real quick. So 9.5, example 2. This one we're going to find the angle. So if I know this is, let's say 4, and this is 10, and we want to find whatever this is, y degrees. Similar question, a little different. We are finding an angle, not a side. So we're working a little backwards. We're working backwards. I'm looking for this angle. I'm given the adjacent side and the opposite side. I'm not told anything, nor am I looking for the hypotenuse, which tells me I'm going to use tangent. I'm going to use the tangent of y is my opposite over adjacent. My opposite, 10 over 4. That is the problem I'm going to be solving. Now, I can't plug tan of y in the calculator. I can't plug tangent of y in the calculator. I can, however, clean up the right side. 10 over 4 gets me 2.5. And we have two different ways to do this. If you have your calculator, it's a lot easier. If you have your trig table, you can still do it. Where we're going to go and find what tangent, what angle approximately spits out 2.5. You could, in theory, sit here and try different angles until you get to here. I don't recommend that, but that's still a way to do it. So if you go to your table, look in the tangent column, and see if you can get close to 2.5, you'll probably be either at the whole number or the half. You probably can't get as much accuracy. If you have a calculator, you're going to do what's called the inverse tangent. We're going to look it up. The inverse tangent tells us to look up what it is. 2.5, so the inverse tangent of 2.5 is somewhere in the ballpark of 68.2. If you had your table, you'd probably say something like 68 or even 68.5 because it does fall in between those two. Any one of those three is okay because the other ones, if you only have your table, you're not going to have as much accuracy. So 68 or 68.5 is really all you can do. But we got 68 degrees this way. Great, that's another version of using trigonometry. Those are the two kind of problems we solve. I didn't have this one labeled, but assuming this was a right triangle. Remember, when we're doing these sort of ratios, it has to be a right triangle. We'll talk about ones in the latter half of this video that are not right triangles. Okay, let's jump to 9.6. 9.6 was not any different ideas, but it did have word problems. I want to start off with this one. 9.6 is the section that honors has a different, harder version that college prep did not go into. So that'll be at the end of the video. We'll do another 9.6. We'll circle back around for the honors people. We have this one. If you need to pause it to copy it down, do so. College prep people, you will remember this was one of your questions on your homework check. A hot air balloon is looking at a landing pad with an angle of depression of 28 degrees. The balloon is 412 feet above the ground. Find the horizontal distance to the landing pad. Now, I'm going to read it, see if I can find things that are relevant. For example, we talked about angles of depression. We have an angle of depression we're given. The balloon is 412 feet above the ground. And we're looking for the horizontal distance. We're looking for this one. I'm going to draw a very simple picture down here. I hope you draw the pictures as well. I think that helps visualize what's happening. But if that's not your MO, then whatever you need to solve the problem. So, here is our hot air balloon. It is some amount above the ground, and then we have a landing pad over here on the ground. Okay, we're still solving a right triangle. So that's our diagram. I put a bullseye. Let me put in the values I know. I know it is 412 feet up. This might not be to scale. That's okay. And I know my angle of depression is 28. If you don't remember, the angle of depression and elevation start from horizontal and go up or down. So if I'm right here, my angle of depression is going to start horizontal and come down. So this angle right here is 28 degrees. If you remember our parallel lines section, not only is this 28 degrees, but this is also 28 degrees. These are alternate interior angles. They both match. So your angle of depression and angle of elevation can live over here on the ground. They can live over here on the ground because they're going to be congruent. Hopefully you can see the problem now. We are looking for, I'll call this D for distance. We are looking for this value right here. We have an angle, we have an opposite side, and I'm looking for the adjacent side. All I have now is just a tangent problem. I took these words, I looked for our key pieces, maybe I looked for angle of depression, angle of elevation, that's always going to be these problems. I looked for some numbers and also kind of look for what we're looking for. So if I wanted to set this one up, is the tangent of 28 equals opposite 412 over d, we'll call it, for distance. Okay? Tangent of 28 is 0.5317 412 over d. And then I can multiply both sides by d and then divide by this. What ends up happening is they swap places. 0.5317. And so d is roughly equal to, I'm going to have to cut off some decimals, more than likely, about 80.9 feet. Feet because we were working in feet earlier. 80.9 feet. So you can see this is not exactly accurate because this is a lot higher than this one. Okay. We have 9-6. There's another honors one at the end of the video. I'll make sure to put it there. Oh, I'm so sorry. I made a very simple mistake. I did not type this incorrectly. It is not 80.9. Sorry about that. 412 divided by tangent 28. Okay, here we go. Better. 774.9 feet. Once again, I didn't type that in right. Take your time, type it in your calculator correctly. Okay, well, let's move on to the other ones. I'm actually going to do a 9-8 problem first, and then we'll jump into a 9-7, 9-8 problem. This one is a little easier. What we're going to be doing is we are finding side B. Using the law of cosines. Using the law of cosines. If you don't remember what the law of cosine is, here it is. I'll copy it down over here so we have it on this page. And what it is this. So a squared equals b squared plus c squared minus 2bc times cosine a. Now these aren't strictly have to be a, b, and c because I'm not looking for angle A. These are just saying the pieces we have and are looking for. So this one is that is our angle. And then B and C are the sides in between, on the either side of the angle. On either side of the angle. And then A is the side opposite the angle. Opposite the angle. So in this case, if you can see, I have a 5, 62 degrees, and 13. That is my B and C, and that is my angle. I'm looking for A. So in our case, it's actually B squared. That's our missing piece. So in our case, it's actually B squared equals 5 squared plus 13 squared minus 2 times 13 times 5 times the cosine of 62. That's actually our version. And if you see here, everything over here is actually a number. I know you see a cosine, C-O-S, but that's actually a number. That's just something we can look up in our table. So all I'm going to do to find b squared, not b yet, is plug in this entire thing into my calculator. You could do it piece by piece. You will get the same thing, but I'm going to plug it in. When I have my variable over here on the left, I'm free to plug this whole thing in. Minus 2 times 13 times 5 times cosine 62. And I get 132.9686. I'm keeping decimals while I'm working, and then I'll cut them off at the end. Very important, I don't have my b, I have b squared. I still have this squared here that has to be dealt with. So make sure you do not stop here. This is not your final answer. You just have to make sure you square root it. So the square root of our answer is around 11.5. 11.5. That is a law of cosines. It's pretty easy because everything's on one side. And if we know where everything goes and we have the equation, we can just plug it in and get an answer. Okay, we'll jump into our final law of sine, law of cosine. For the college prep, this is going to be your final question. Honors, you have one more after this. We have this, we're solving the triangle, and the reason this one's last is because we're going to have to use both versions, both laws to figure it out. I have a couple things, let me put some letters to these. How about E, and then that'll be F, and that'll be G. That way we can just talk about different pieces. Solve the triangle, it means find everything that's missing. What's missing, we have no sides missing, we actually have 3 angles missing. So we're going to find E, F, and G. Doesn't matter what order we do it in. Just for starters, I'm going to find E. That's going to be my first one. I'm going to find E first. Well, first thing I'm going to do is just a law of cosine. A law of cosine. 17 squared equals 20 squared plus 22 squared minus 2 times 20 times 22 times the cosine of E. The reason 17 is here and not 20 or 22 is because 17 is the opposite side from the angle. So these are my B and C because they're next door, they're flanking the angle. 17 is the opposite one, so it kind of goes on the odd side of it. Kind of goes on the other side. Well, I have mixed up a variable deep in here, so I can't just plug this all in. I actually can't even plug this all in because this is being connected to a variable. This is like 2x, and how, we can't say something like 4 plus 2x is not equal to 6x, right? We can't smush those together, and that's what's happening here. These are just numbers, and these are numbers with a variable. What I'm going to do is turn this little set into a number. I'm going to clean up this one, and then I'll solve it. So let me square 17. 289 equals 20 squared plus 22 squared, 884 minus 2 times 20 times 22, 2 times 20 times 22, 880 cosine E. Once again, we cannot turn this into 4 cosine E. This is locked together and they can't play with this one. So I'll just move it over to the other side. I'm going to get a negative for just a moment. So we have 289 minus 884. Negative 595 is equal to negative 880 cosine E. Okay, all I'm going to do next is divide this away. It is a little difficult, but the good news is we go through the same rhythms every time. These kind of problems have the same little patterns again and again, so doing them enough should hopefully help you realize what's going on every time. So I get to cosine of E is equal to 0.6761. Go to my table, see if I can find the closest thing to this, or I do a reverse lookup. I do the inverse cosine. Whichever one. If I'm looking up the angle, I'm doing the inverse cosine of 0.6761. And I get E to be approximately 47 and a half. 47 and a half. So I have a couple options now. I need to find F and G. Remember, we're solving this triangle. We're finding everything that's missing. I know one of these angles, 47.5, and I could do this whole thing again with a different number here. I could say the 20 now goes here, and then 17 and 22 are here. I'm not going to do it that way. I'm going to show you law of sines. We talked about it earlier. The law of sines, if you remember, is the sine of an angle over its opposite side over the sine of another angle over its opposite side. For example, I'm going to find F. I could have found G. They're going to be the same idea. The sine of 47.5 over 17. The reason 17, because they are connected. And if I'm looking for F, I'm going to use 22. Those are my little pairs. Sine of F over 22. That's the ratio I'm going to solve now. Well, I can just turn this whole left side into a number. Sine of 47.5 divided by 17. I'm just going to turn this whole thing, put that in my calculator, and get 0.0433 equals sine of F over 22. Let's multiply by 22. Equals 0.9541. And then all it's left to do is look up on our table, see if we can find this, or the inverse sine. The inverse sine, to find the angle, 0.9541. I get 72.5 just about. Okay, and now, for the last one, I actually have 3 different options. I could do this again, using G now instead of what we did for E. I could do this again, using G instead of F. But I would recommend all you do is say, well, I have 180 total. I've already used one. I've used another. What is left over? 180 minus 72.5 minus 47.5. This should be somewhere around 60 degrees. All right, that is a problem where we're solving it using different pieces. And then, so that equals G is 60 degrees. That is a problem where we can use law of sine and law of cosine to get to the answer. Okay, if you are college prepper on level, that is where your ideas stop. I tried to cut off all the things we did from the quiz, just because A, that was a while ago, and B, you can focus on one thing, master that one thing for this test, and all the videos are available to you. Now, if you're on honors, stick around. I have one more for you. It's actually the one from your little notes check. Here we are. The angle from the ground to the top of a radio tower is 56 degrees. At a point 170 feet farther back, the angle from the ground to the top of the tower is 39 degrees. How far is the first point from the base of the tower? Okay, let me get a marker to underline some of our important pieces. The angle from the ground to the top of the tower is 56 degrees. That is an angle of elevation. At a point 170 feet farther back, the new angle is 39. And I want how far is the first point away. Okay, well, I'm going to draw a very simple diagram. There's my tower. I have 2 different distances away. I have one that is 56 degrees away, and I have another that's 39 degrees away. I don't know this. I don't know how far away that point is from the tower. So I kind of don't know this. I also don't know how tall the tower is. I kind of don't know this, but I do know that this is x plus 170. X plus 170. Now, this doesn't look like enough things to do the problem with, but it is. We actually have two triangles in this problem, two right triangles in this problem. The first one is this small one in blue. The first one is the small one in blue, and the second one is the big one in red. They share some pieces. You can see they share the tower, they share a little bit of the overlap here. And we actually have two variables because we can make this basically one variable because it's just referencing the same thing. And we can figure this out. So let me figure out how to do this. Let me start over here and then I will move along. So here is 1, here's 2. We don't know this. We don't know this. We know this is just x, 56. We know this is 39. And this is actually x plus 170. So that's two problems. If we were to break this up into two simple trigonometric functions, we have those. Well, I'm not solving anything yet. I'm still setting up. I can set it up like this. The tangent of 56 is equal to the opposite over adjacent. The tangent of 39 is equal to the opposite over adjacent. Okay, we have two options now. We can try to isolate x, or we can try to isolate y. I'm going to isolate y and then plug it back in to get x. It's going to be just a tad bit slower. If you want to isolate x by itself and you feel comfortable getting the right answer, you go for it. Please trust yourself, trust your gut. I'm going to isolate y because it's going to be a little bit easier. So there's I'll continue my blue triangle work over here and my red triangle work over here. So that way you can follow what's going on. Blue triangle, very easy. I'm just going to multiply by x. So I get this. Y equals x times the tangent of 56. And I'll just turn that into a number while I'm here. I don't want to keep carrying that around at the moment. You could. Y equals 1.4825x. Okay, that's my blue triangle. It's not an answer, but it's another way to think about it. Over here, I have the tangent of 39. Tangent of 39 is 0.8097 x plus 170. I'm going to multiply that on both sides, equals y. I multiplied the denominator on both sides. I'm also going to distribute to both of these. 0.8097x plus, that's going to give me 137.6632 equals y. I'm going to go down to the next page. Copy this back again. So my blue triangle is still over here, so you can follow what's going on, and my red triangle is still over here. I want to make sure I keep my work where you can follow it. My last step gave me this, 1.4825x, and y equals 0.8097x plus 137.6632. One of the reasons we're isolating y is because y is the thing that they both have in common. They both have the height of the tower in common. It's not being asked for in here, but we can use it to find what we want. So we have these two, and all I have to do is set them equal. If y is this and y is this, those things can come together and make 1.4825x equal to 0.8097x plus 137.6632. The decimals are a little cumbersome. 4 might even be overkill with a problem like this, but it's still okay to do because I'm only doing a couple steps. Let's subtract this on both sides. 8097x 1.4825. The most common way you could get this wrong is by just doing something simple, putting in the wrong number in your calculator, dropping a decimal, dropping a negative. So go slow. Most of this stuff is not hard math. Maybe the process is difficult, but everything you're doing is just adding, subtracting, multiplying, and dividing. So keep that in mind. Know that every one of these problems, you're going to have two triangles that you're trying to set up to be the same thing. 0.6728. And then what we're going to do here is isolate x. We're going to have x by itself, and that is going... actually, that's going to be our answer. That's great. I isolated y, and that gives us x. 137.6632 divided by 0.6728. And I got x equal to 204.6. And I believe we're in feet. Yes, we're in feet. So there you go. What I did is I mapped it out into two right triangle problems. Two right triangle problems. A smaller one from x and a bigger one that can be in terms of x plus 170. Like this right here was 170 and this was x. So the whole thing was x plus 170. I just got them in terms of their ratios. With these ratios, I could isolate a variable. I chose to isolate y. That's pretty straightforward. It was there at the top. And then once I had both things being y equals something, I can just put those together, dropping the y's, obviously. And then I found what x was. If I found what y was, I could come back in probably this one, plug y in, and get my variable. Okay, I hope that makes sense. I hope that's pretty straightforward. I know that problem's not super easy, but I think it's the same kind of problem again and again. Remember, you will have these pieces. I'll give them to you. You have to memorize them. You just have to know how to use them. We're cutting off the stuff pre-quiz, saving that for the final, just so we can have a more focused test and you have fewer things to study. I miss you all very much, but I know you're going to do so well. Signing off.